If you are an engineer, you would like to hear of a Matlab, but it's often misunderstood as just a tool for plotting graph or a fancy calculator. In reality, Matlab is a high-performance language and environment designed specifically for numerical computation, simulation, and iterative problem solving core task in engineering. Unlike general purpose language, MATLAB syntax is intuitive, its toolbox are domain specific, and its visualization capabilities are immediate. For engineers, it bridges the gap between theory and application, which enables rapid prototyping, data analysis, and algorithm development without getting bogged down in low level code. First core concept will be the MATLAB workspace and work variables. Think of the workspace as your engineering lab bench. Every lab you create scalars, vectors, matrices sits here visible and modifiable. No explicit declaration needed. Everything is a matrix. Even a single number is a 1 cross 1 matrix. The unified structure is a key to MATLAB's power. Second core concept matrix operations. Matrix operations will be the heart of the engineering mathematics. Engineering problems are from circuit analysis to structural mechanics. It often boils down to system of equations. MATLAB's matrix native approach lets you solve this intuitively. Instead of writing loops, you operate on entire data sets. MATLAB. This example will be shown here. Third concept will be visualization and debugging. See your design. MATLAB plotting function turn abstract numbers into actionable insights with the commands like plot, surf, stem, which can visualize the signal responses and stress distributions or field patterns in minutes. Tips Pro tip, it uses the debugger and display function to track the variable changes essential for verifying simulation logic. Fourth concept, script versus functions. Organize your workflow. Scripts, a sequence of commands like a lab notebook. Functions, reusable parameterized code blocks, specialized learning path for engineers. While MATLAB basics are universal, applying it effectively requires domain-specific knowledge. Here are tailored pathways to accelerate your mastery. MATLAB Fundamentals for Engineers, a comprehensive start point covering the syntax, data analysis, and basic modeling. By clicking this link, explore the course link. For MATLAB Fundamentals for Mechanical Engineers focuses on dynamics, thermodynamics, and control system simulations. Click on this by clicking dive into mechanical applications. MATLAB fundamentals for electrical engineers emphasis on signal processing, circuit analysis, and power systems. By clicking master electrical engineering tools. Why this matters for your career: accelerated prototyping, data driven decisions, interdisciplinary collaboration, industry adoption. Mm, The example for MATLAB experiment is you have just simulated the real world sensor noise. This will be a common engineering challenge. Next steps in this is practice daily, explore toolbox, join communities, discuss with prompt engineers. Stay tuned to next issue.